Okay, so today we're going to talk about what is on the Chapter 3 test. Test 3. This test consists of confidence intervals and hypothesis testing for means and proportions. So first thing we're going to talk about is confidence intervals. And so what we're going to do is we're going to make a line going down the center of the paper because we're going to separate it into proportions on one side and means on the other side. So we'll do this. Oh, that was ugly. So we're going to do proportions. I haven't written on this pen for a while. So proportions here. And we're going to do means here. All right, so we're going to do confidence intervals first. Remember, no matter what chapter you're doing, whether it's confidence intervals or hypothesis tests, ZAP-TAM, Z is always proportions, T is always means. So when doing proportions, which are just percents, you're going to use the Z. When you're doing means, which is your averages, you're going to use the T. All right, so let's talk about confidence intervals first. So confidence intervals. Okay, so confidence intervals for proportions, you go out and remember you go get a point estimate for any type of confidence interval, plus or minus, and then it's always going to be a Z or a T, and then something called a standard error. Remember that the whole plus minus part is called the margin of error. All right, that's the whole plus minus part. All right, and sometimes you're given the point estimate and then the plus minus part, you just take it, add on to it, subtract off of it, and that makes your interval. All right, so let's go back to, let's do proportions. I'm going to do these in purple. So proportions, you're going to go out and get your point estimate, which is a p hat. It's just a little sample percent, then plus or minus, a z, big square root, p hat, q hat, over n. And remember, p hat just comes from you going out and asking a group of people something, which is n, and x is the success, like how many people said whatever question you're wanting out of it. It's just binomial. So like you ask people if they were going to the game this weekend, and they said yes, and that would be your x. So it would be how many people said yes out of the total. So on the calculator, remember everything is under stat tests in this whole, all of test 3, all of this material is under stat tests. Let's move this up a little bit. So you're going to go to stat tests, and this one is at A, and it is 1 prop z int. And remember that that x has to be a whole number. And if your x ends up being a decimal, then just use 0.5 rounding rule. All right. Make my line going down. Continue with that. All right, now over here, I'll do blue. No, we did blue. We'll do green. Okay, over here, we're going to do the mean. The point estimate for this one is x bar plus or minus t, and then the standard error is s over the square root of n. On your calculator, it is number 8, t interval, and basically both of them have the same sentence. So for confidence intervals, your sentence will be, I am blank percent confident that the true proportion, if you're doing proportions, means if you're doing means, and you make sure it's in context here, is between whatever your two numbers are, and either they're going to be percents if they're proportions or whatever the units are if it's a mean. Okay, so that's a confidence interval. So next thing up is the sample size questions. Okay, so that's your confidence interval. Next thing is sample size. Okay, sample size for proportions. What color was I doing for proportions? I think it was purple. Yeah, okay. Sample size for proportions is n equals p hat q hat z over e, and then this part is squared. Remember e, turn that into a decimal. They're going to give you a percent error, like I want to be accurate within 3%. Make sure you change that to 0.03. And then remember you default to, for those, 50%, 50-50, if you're not given any p hat and q hat in the problem. Over here, we do n equals, and then this one is z sigma, that is your standard deviation, in your error squared. And then doesn't matter, always round up. Always round sample size up. Okay. My suggestion to you is that for the z's, I would write them down. I would say 90 is 1.645, 95 is 1.96, 98 sometimes we use is 2.33, and 99 is 2.575. That is used here, here, and up in the formula up here for proportions. So those are your most common ones, but you're always allowed to have your Z and T chart with you. Remember that for any of the Z and T's, you can use inverse norm for Z, right, for the Z, and you can use inverse T for the T, and both of those are under second bars. Inverse norm, you have sometimes a choice, but sometimes it says area to the left. The default is area to the left. So if you're doing a 95% confidence, your area to the left is 0.025. Over here, if you're doing a T, it's always area to the left. So if you're doing like a 98, you're going to do 0.01. Remember that the 83s do not have this, and you have to use the T chart. All right, so that is confidence intervals. We'll talk about hints of when they're asking you that at the end. Let's do the formulas for proportion and means and go through the whole hypothesis test. So we are still doing proportions here, still doing means here, and now we're going to talk about it with hypothesis testing. Okay, so we're going to go through and do a whole hypothesis test with proportions, and then we'll go back through and do it with means. So purple, here we go. The HO for proportion is P equals, and that is going to be a decimal. It's a percent, you write it as a decimal. The HA is less than, greater than, or not equal to. You draw your curve and you shade, and it always comes from the Z. And you can use inverse norm for that. So that's your critical value. Remember, this is your CV, which is called your critical value. Then after you do your critical value, you go and gather your, and you do the formula for Z is P hat, that's your sample, minus your population, over, and the rest of it is all population, P, Q over N. These are your HOs. These are the numbers from the HO. Okay. And then on your calculator, it is 1 prop Z test, and it is number 5. And just like with confidence intervals, your P hat comes from your sample, your sample out of your total. All right, so that is for proportions, and then we'll talk about rejecting in your sentences in a minute. Okay, so over here for means. I think we were doing green. Your hoe for your mean is mu equal, and it's going to be some number about the population. Remember, it's always a population number. Your ha is going to be mean is less than, greater than, or not equal to. Your drawn shaded curve is going to come off of the T chart, still called a critical value. Your formula for T is x bar minus mu over s divided by the square root of n. And this one is number 2, T test for hypothesis test. All right, so down the center, let's write what all of these are. Okay, so in red, no matter what the test is, this is called your null hypothesis. It's before you do any data. This is your alternative hypothesis. This number that you get from the chart, where the shading starts, no matter what kind of test you do, okay, is called your critical value. This is called your test value. This is you test to see where it lands, test value, or test to statistic. Oh, I couldn't say that. Okay. Remember that everything in this chapter and confidence interval in both of these chapters is under stat, and then arrow over to test. You will find your confidence intervals and hypothesis test there. All right, now the next part is all the same no matter what kind of hypothesis test you're doing. So let's write a red line here. So after you do all that, you're going to take your test value and you're going to see where it lands. You're going to reject the hoe. And you write reject the hoe if it lands in shaded. If it lands in white, you're going to say fail to reject. You're also going, sorry about that. You're also going to reject the hoe, remember, if your p-value, which is written on your calculator, right? Your p-value is less than your alpha. Remember, we default an alpha to 5%, and we default confidence intervals to 95%. All right, so your two sentences that you need to understand and interpret is the p-value sentence first. What is a p-value? Okay, a p-value is there is a chance, a blank percent chance, whatever the p-value is that you get off your calculator, of getting the same, I'm trying to write, not in cursive, sorry, sample proportion or mean again of whatever the number is, again or more extreme, based on the true proportion / mean problem. Okay, so this just comes from this number here, just comes from the calculator. That's just what the P is on the calculator. Change it to a percent. This is either your sample mean or your sample P hat. This last number is, there's some number here, your true proportion of whatever your true proportion is, or whatever your true mean is. This is the number that's going to come from your hoe, right? That's the hoe number, right? So you fill it in, calculator, whatever the sample mean or sample percent was, and then whatever the hoe was. That's your population, so either the mu or the p sub 0. Sorry, the bell's ringing. It's your p-value sentence. Now, you'll have a reject sentence. Reject sentence, you will say, there is evidence to suggest that whatever it is, that the whatever proportion that the hoe, that it is, let's say this, that it is not, let me cross that out, that it is not the hoe. Let's say the sentence that way. Whatever the hoe is. If it's a mean, you say it's not the mean. It's not the proportion. You're trying to reject that center, right? That's what you're doing when you're rejecting. You're trying to reject that center. Okay. If this is a fail to reject, if this is a fail to reject, you're going to say fail to reject. That means you ended up in the white area, right? And you say fail to reject, and you just add this right here, no evidence. That's the only difference in the sentence. So if it's a fail to reject, you say fail to reject, there is no evidence. And then if it is reject, you say there is evidence. You are trying to take a curve, and here's your hoe. And if you land in shaded, you're going to reject. And you're going to say, okay, I have evidence to say it's not this anymore. Then I'm going to shift this whole curve up. That's what you're trying to do in a hypothesis test, whether it's any kind of hypothesis test that it is. All right, last thing is all the little details and stuff. All right, I'm going to go to a new page here. All right, so you're going to have confidence intervals and hypothesis tests and sample sizes all on the same test. So if it is a confidence interval, the questions are going to be construct an interval. Okay, they're going to say construct, or they're going to say find the interval. You're going to see numbers in the 90, 95, 99s. If it is a sample size, and this is all on that sheet that we did with the formulas during confidence intervals, there's specific sentences that you look for. Go back to that formula sheet and make sure all of that is on your help sheet. All right, so sample size is what is the minimum size needed? Okay, how many people should I ask? How many do I need? How many should I ask? What is the minimum number of things that I need to sample? Anything like that. A hypothesis test is that they're going to give you a whole bunch of numbers and they're going to tell you what it is right now. If they asked you questions, is there evidence? Is it significant? Can you support or you reject a claim? Those are all going to be hypothesis tests. Okay, the next thing is errors. So there's two types of errors you can make in hypothesis testing. The first one is your type 1 error. So a type 1 error is when you rejected, but you shouldn't have rejected. Okay, the probability of that happening is your alpha level, because if you do a hypothesis test, your alpha level is this area where you reject. And if you made a mistake, that means you landed in here and you shouldn't have rejected. Type 2 error is when you fail to reject, but you should have rejected. Okay, the probability of that happening is something called beta. And that means you landed up here in white, but really we should have moved this hoe. We should have rejected it and we should have moved it. Okay, the symbol for it is B and it is beta. Remember, that's your alpha right there up here. Okay, power. Power is 1 minus B, which is beta. Power is the strength of your test to reject when you should. Okay, what that means is that if your type 2 error is 10%, that would be your beta, then power is 90%. That means there's a 90% chance of you rejecting when you should, that you did the problem right and you rejected and you should have rejected. Right, and then last thing is the link between confidence intervals and hypothesis tests. Okay, so there is a link between confidence intervals and two-tailed. It has to be a two-tailed test. So if you do a confidence interval at 99%, that is exactly the same as a two-tailed test with an alpha of 1%. Remember, your alpha is your total shaded area. Okay, so a 95% confidence interval is the same, that's a 95, sorry, is the same as a two-tailed test at 5%. And they are interchangeable. So if you do a problem, and I'm going to go down to here, need to do a new paper. If I do a problem, and let's say it's a mean problem, and I say my hoe that my mean is 10, and I tell you to test it for a ha of not equal to 10, and remember, it only works with two-tailed tests, at an alpha of 5%. So if you were to draw the curve and shade it and find the critical value, you would do this, you would do this, and that would be 0.25. That is the same as a 95% confidence interval. So instead of doing a hypothesis test here, I could construct a confidence interval instead of a hypothesis test. So let's say I go and I construct a confidence interval and I get an answer of 8 to 12. The hoe, you then test the hoe. The hoe is landing inside the interval, which means it's landing in the white, and I would fail to reject. So this would be a fail to reject since it is in the interval. Okay, let's say I was doing the same problem and still 95% confidence interval. So that would be an 0.25 and 0.25. Remember, this only works with two-tailed tests. My hoe is still 10, and I got an answer of, for my interval, 11 to 16. Well, 10 lands here, which would be in the shaded area. So I would reject, since 10 is not in between 11 and 16. So I would reject since 10 is not in the interval. Okay, that is test 3.